Okay, 6.10 is integrating with long division and completing the square. It says completing the square and long division are two skills that help us manipulate the integrand until it becomes something we can work with. So those are the two skills we're going to practice today. So long division, raise your hand if you remember it. Okay, not too bad. It's something you learn in Algebra 2, well, you're supposed to, and then pre-cal. Okay. So, honestly, in this notes, there's nothing new calculus-wise, okay? Everything here we've already learned. It's just bringing in those skills from Algebra 2 and pre-calc with the long division and completing the square. So, for number 1, we have the integral of this fraction, and we know we're going to end up using long division for one of two reasons. Let's say we look at this and we're like, okay, well, maybe I'm going to use u substitution. Pick whatever you decide. You'll notice that when you're solving this, you're still going to have things in terms of x. Okay, so we have to do long division in order to simplify this so we can create multiple integrals that are easier to integrate. So for those who don't remember how to do long division, the idea is that we look at the first term here and the first term here, and we ask ourselves, okay, what can I multiply x by to get 3x cubed? Anyone? 3x squared. Okay, then I take that 3x squared and I'm going to multiply it by the x and the negative 2. Okay, so I have 3x cubed minus 6x squared. I then change the signs. So it's now a negative 3x cubed and a positive 6x squared, and add everything down. When I do that, that first term should cancel. Okay, so I have negative x squared plus 6x squared, so this is 5x squared, and I bring everything else down. So minus 5x plus 1. And then I just keep doing that until I either left with nothing, a 0, or I am left with a remainder. Okay, so then my next part is, okay, what can I multiply x by to get 5x squared? 5x, so plus 5x. So I have 5x squared minus 10x. Change the signs, add down, the first term should cancel. Then I have 5x and bring down the 1. And then I'm looking at the next part. What can I multiply x by to get 5x? 5. So 5x minus 10. Change the signs. Add everything down. First term should cancel. And then I'm left with 1 plus 10, which is 11. Okay, when you get down to here, you'll notice there's no x left, so I can't figure out what to multiply to get to 11 because I can't. So what happens is what you learned in Algebra 2 and pre-cal is this just becomes the remainder of 11 over what you were trying to divide by, so x minus 2. Okay, any questions on the long division? All came back to you guys, so you remember all of this? Okay, perfect. Okay, so now on to calculus. What we're going to do from this is we're going to actually write this as two integrals. So this is the integral of 3x squared plus 5x plus 5 dx. Okay, so whatever we got for the answer. And then we're going to add the integral of what the remainder is. So 11 over x minus 2 dx. Okay, that first one is very easy to integrate because we're just using that idea of the power rule. It's a polynomial. We would end up adding 1 to the exponent and then dividing by that new exponent. Okay. For the second integral, we're going to have to use what to solve? U substitution. Remember, these notes is everything we've already learned. Okay, so it's nothing new. We're going to use u substitution. So let's go ahead and just solve that first integral of the polynomials. And then we'll move on to the u substitution part. So if I'm integrating 3x squared, what is that going to turn into? 3x third over 3. And then I have plus 5x to what?
The second
Over 2. Right? It's whatever that new exponent is. And then plus 5x. Okay, so that is us integrating that first integral. Okay, I'm going to leave it as is because now I'm going to solve the second integral and we're going to attach it all together for one giant answer. Okay, so for here, I'm going to let u equal what for my second integral? X minus 2, which means du dx is equal to 1. I take the derivative of both sides. Okay, I need to solve for dx, but since this proportion is equal to 1, that means they're equal to each other. So really, I have the integral of 11 over u du. I can simplify this by doing what with the 11? Take it out. So 11 integral of 1 over u du. And based off previous notes, I know that this is going to be what? The natural log. So this is 11 natural log of the absolute value of u. And then we plug u back in, so we have 11 natural log absolute value of x minus 2. Well, we just have to attach this to the other integral that we already integrated. Okay, and I can even simplify this by saying that this is just x cubed, because 3 divided by 3, plus 5 halves x squared, plus 5x, plus 11 natural log absolute value of x minus 2, plus what? C, plus c. Let me erase this real quick. Okay, so that's the answer. So again, it's not hard.
It's just lengthy.
Okay, it's lengthy. That's what makes it fun. Right? I'm telling you, we're going to get to a problem. I mean, not as much as when you're actually in college, but you're going to have a problem where it's going to take you like 3 pages front and back to solve. And it's just going to make you feel amazing. Then you have to start it all over.
I think it's hard to be a business major.
Of course, that's only going to be true if you're going to go into, let's say, engineering. A lot of you sigh, yeah. Or pure math. Okay. So, number 1. Any questions? Okay, so number 2. Same concept. We have a polynomial divided by another polynomial. So that is our cue to do the long division. Okay, so I'm not going to explain step by step this time because you guys said you got it, right? Unless someone needs me to. I just need one person to say, yes, explain step by step. Okay. Okay, so long division. So what can I multiply 3x by to get 6x to the 4th? 2x cubed. So I have 6x to the 4th minus 10x cubed. Change the signs. First one cancels, and I'm left with 3x cubed. Bring everything else down. Okay. Now what would I multiply 3x by to get 3x cubed? X squared. Don't you guys miss this fun math?
Yeah.
Yeah. Okay, change the signs, add everything down. The first term should cancel. So I have 6x squared, bring down the 2x. Okay, what's my next one? Multiply it by 2x. So I have 6x squared minus 10x. Change the sign. First term should cancel, and I'm left with 12x. Okay, last one. 4. So I have 12x minus 20. Change the sign. First term should cancel. And then I'm just left with a remainder of 20, which becomes 20 over 3x minus 5. Okay, so this told me what? How many integrals am I going to have? 2. Okay, so here's my first integral. 2x cubed plus x squared plus 2x plus 4 plus the integral of 20 over 3x minus 5. Oh, I forgot dx in the first one. There's a bit of a lag I'm noticing on the board. Okay, so this time let's go ahead and start with the second integral instead. So let's start with the u substitution. What would we let u equal? Good, 3x minus 5. Let u equal 3x minus 5. So du dx equals 3. The derivative of 3x minus 5 is 3. Okay, we need to solve for dx. And I get that dx is equal to du over 3. Okay. Then I plug everything in. But before I plug everything in, what can I do with that 20? Bring it to the outside. So I have, this is equal to 20 integral of 1 over u du over 3. Which means I can also take out a what? 1/3. So this is 20/3 integral of 1 over u du. Okay. We know that the integral of 1 over u is going to be natural log. So this is 20 over 3 natural log absolute value of u. Okay, then I just plug u back in. So this is 20 over 3 natural log of the absolute value of 3x minus 5. Okay, and I solved the quote-unquote hard one, right? I did the u substitution for that second integral. Then I just need to go back and solve the other one, put them together, and not forget plus c at the end. Okay, so let's look at the other one. So we have 2x cubed plus x squared plus 2x plus 4. What would be 2x cubed after we take the integral? 4, good. What about the next one? X cubed over 3. Next one? 2x squared over 2. The last one? Plus 4x. Okay, so really I have 1/2 x to the 4th plus 1/3 x cubed plus x squared plus 4x plus 20 over 3 natural log of the absolute value of 3x minus 5 plus c. That's my answer. Yes, question.
So would you have this as like an evergreen question?
Mm-hmm.
Yeah.
Say that one more time, sorry.
Would you have this
not likely to look like this. Not likely to just say, find the integral, right? It's going to be more of, usually those FRQs are going to be more word problem based, kind of like the ones that we've seen before. So you might have a problem where you'll have to solve this, but then you're going to have to use this integral for something else. Something like this would probably be more multiple choice. Okay. Any questions on long division? Bless you. Okay, so the next one is now completing the square. Okay, so for these notes and for the practice and homework, they are going to say use completing the square. They are going to say use by long division, solve by long division. However, when you're given a problem, let's say on a test, it's just going to have the integral there and you're going to have to figure out how to solve it. Okay? There is no like rules to say like if it looks like this, follow this path. Okay? So a lot of these integrals, you're just going to have to do trial and error until you get really, really good at using all the tools that you know. Okay? So for example, if you had something like this, before I even told you, okay, completing the square, what would have been some of your guys' first instinct? Use substitution. So what would you let u equal? Good, the whole denominator. Okay, if I was to take the derivative of u, which is the derivative of this denominator, would I be left with x values? I wouldn't. 2x plus. Okay, this is what we're saying out loud. We're saying if we say let u, don't write this, x squared plus 6x plus 10, then du dx is equal to 2x plus 6. So are we left with x values?
Yeah.
Yes. Okay, so if I was to plug this in, this would be 1 over u du over 2x plus 6, something like that. Okay, are we able to integrate if we have two variables there? No, so that should be your clue of, okay, u substitution does not work. Okay, then you look at your other tools in your toolbox and you think, okay, can I do long division? Well, can I take a polynomial and divide it into 1? No, it's not going to tell me nothing, right? So then you lead up to completing the square. Raise your hand if you remember how to complete the square. 1, 2, okay. Don't worry, I'm going to teach you. It's super easy. Okay, you're going to take that polynomial. So x squared plus 6x plus blank plus 10 plus blank. This is how I teach it to Algebra 2. Okay, the reason why we're adding in those blanks is because ultimately what we're going to do is add 0 to the problem. Okay, and we want to do this because these first three terms we're trying to make a perfect square so we can rewrite this. So if we look at the b value, which in this case is 6, we're going to divide that by 2. So what's 6 divided by 2? 3, and then we're going to square it. What's 3 squared? 9. So we're going to add 9 and then subtract 9. Right? Is that the same as adding 0? Yes. Okay. Well, now we're going to take this first three terms and we're going to turn it into a perfect square. Well, in order to do that, we need to, again, look at our b value, which we said was 6. And when we divided it by 2, we got 3. So x plus 3 squared. Okay, we just completed the square for the first part. The last part, we're just simplifying. So what's 10 minus 9? 1. So what we just wrote here is the same as this quadratic. They're both the same. Because we could end up foiling this out and then combining like terms and adding 1. We'd get the same thing. So that's what it means by completing the square. The reason why we complete the square is because when we plug this back into the integral, we should see something that looks familiar. So let's go ahead and plug that back in. So we have the integral of 1 over x plus 3 squared plus 1 dx. Okay. And this should remind you of one of your inverse trig functions?
Tangent.
The inverse of tangent. Good, because remember, the inverse of tangent is 1 over x squared plus 1 when we take the integral. So the derivative. So they are opposites of each other. So again, there is no way to say, after this step, you must do this. It's what do I know from everything I learned in this unit, and how can I apply it? So since we want this to end up being something where it's x squared plus 1 on the bottom, that tells you our next step is to use what? U substitution. So let u equal x plus 3. So du dx is equal to 1, which means that du is equal to dx. So if I plug that in, I have the integral of 1 over u squared plus 1 dx, which I know because I have all of my inverse trig memorized, as a good BC student should. Okay. Oh, not dx, du. Okay. And so I know that this is arctangent, or I write this as the inverse of tangent u plus c. And then I plug in u, which was x plus 3. And that's my answer. Okay, so more often than not, if you need to use completing the square, most likely your answer is going to have an inverse trig function in it. Not saying always, saying more often than not. Any questions on 3?
I must say, I haven't used my second degree yet, but the last problem was the one.
Yeah, number 5. We're going to end up doing number 5. But I'm going to let you guys think through it critically.
Did you say you couldn't do number 5?
I know how to do number 5. It just took me a while to figure out how to manipulate the problem.
It doesn't look bad, but, you know.
It doesn't look bad. I only did it 5 times till I figured it out. And I want to say 5 times until I ran to Miss Wong saying, help me, I can't figure this out, so. Okay, we're not there yet though, on number 4. Okay, so number 4, again, let's say you don't know this is completing the square. Your first instinct would probably be u substitution because we have that square root. Just know that if we have a large polynomial like this, when we take the derivative, we're still going to have x in our problem. And we want everything in terms of u. So I'm going to look at this polynomial, and I'm first going to take out a negative. Okay, it's yucky completing the square with a coefficient in the front, so I'm just going to take out a negative. So when I do that, I'm left with x squared minus 8x plus 15. I'm just changing all the signs. Okay. Then I'm going to do completing the square. So I have x squared minus 8x plus blank plus 15 plus blank. Okay, I look at my b value, which is -8. Always include the negative. I take -8 and divide it by 2, which is -4, and then square it. 16, so I'm going to add 16 and then subtract 16. Because ultimately, what am I doing? Adding 0. Okay, which means this first 3 terms is going to become x minus 4 squared. Good, because we look at our b value and divide it by 2. Okay, -8 divided by 2 is -4. That's how I got my perfect square. And then I just simplify the outside term, so what's 15 minus 16? -1. Okay, so now I have the integral of 1 over the square root of -1 times x minus 4 squared minus 1 dx. Okay. So from here, what I want to do is actually want to distribute that negative 1 in, which makes the x minus 4 squared negative and then that negative 1 positive. And the reason I'm doing this is I noticed that this looks a little similar to which inverse trig? Sine. So if you said sine, that's correct. Okay, so this is going to be the integral of 1 over the square root. And since I'm making that first term negative and the other term positive, I'm just going to switch them. So this is 1 minus x minus 4 squared. Everyone follow me. How I went from the first step to the next step. Okay, now if you didn't see it before, do you see how this looks like arc sine? Okay. The only thing left that we have to do is use what? Use substitution. And we're going to let u equal x minus 4. So du dx is equal to 1. So du is equal to dx. So I have the integral of 1 over the square root of 1 minus u squared du, which resembles arc sine. So I know this is going to be the inverse of sine of u plus c, and then I just have to substitute u back in, which was x minus 4. And that's my answer. Any questions on 4?
What's the little symbol in the inverse of sine?
It's just a u. I did it extra cursive-y. Yes. How did I distribute the negative? Okay, so I gave the negative here, which made it negative x minus 4 squared. That's this part. Okay, then I distributed the negative 1 to this negative 1, which make it positive 1, which is this part. I just flipped them. So instead of saying negative this plus or minus 1, I did 1 minus that, just so it looks like that inverse trig. Okay, you guys ready for 5? Okay, so the first part of 5, what I'm going to do is I'm going to have you guys tell me what I should do. Okay, if I change colors, don't write it on your paper. Okay, that means it's not right? But I still want to see your thought process. Okay, so take out the 32. That's good. Okay, anyone else? What's the next step?
Find the square of x squared minus 4 plus 1.
Good, so complete the square. That is correct. So x squared minus 4x plus blank plus 20 plus blank. What is going to go in this first blank?
4.
Good, so negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So plus 4 minus 4. Okay, so that leaves me with what?
X minus 2 squared plus 16.
Good. Remember, once I change color is when it's not correct. Just keep that in mind. Don't write it if I change the color. Everything so far, good. Maybe you guys will get it on the first try.
How did first period do?
I'll tell you after the recording. I'm recording right now. They all did wonderful. Of course they did. One person made me feel very not smart because they figured out first try, but it's okay.
Was it well?
It was someone in first period. You guys are making me lose concentration. Okay. Okay. Next step, what's your thought process?
Do you move the 32 back in to cancel out the 16?
So let's say we moved it back in. Okay. Can this really cancel out a 16 if it's plus 16? No. When could it cancel it out? If there was times 16. Okay, so
No, because
It does the thing.
it does the thing.
32 over 16 includes the 1, or 2 at the top. And so the 16 on the bottom is removed.
So because if we were to separate this into two fractions like you're saying, 32, there's only one term on the numerator, so I can't separate it into two fractions.
Oh, shoot.
That entire thing is the denominator.
Yeah.
Okay, good thinking. Any other ideas?
Use substitution.
Okay, use substitution for what?
X
X minus 2.
Okay, so let u equal x minus 2. No, we're going to go through the process because this is what I did first. This is what I did. Okay, let's go through the process though, because the whole point of learning how to do these is the trial and error part. You're going to get better. Okay, so du dx is equal to 1, so du is equal to dx. Are we writing this part? No. Okay, so let's say we plug it in. This is 32 integral of 1 over u squared plus 16 du. Okay, I did exactly this. This is where I got stuck. So if you were doing these same exact steps, what would be your next step?
Double use substitution. Go like
Double u substitution for what?
U squared plus 16.
Okay, let's try. Let w, trust me, I did this too. U squared plus 16, so dw du is equal to 2u, which means that d 2u du is equal to dw. So du is equal to dw over 2u. Okay, we plug this in. You're going to see what's wrong here. We have 1 over w dw 2u.
Two variables.
There's two variables. It doesn't work. Okay, so let's say we didn't do this. Okay, we're still here. What would be your next thought process?
Cry.
Cry. Trust me, I did that. I cried. I crumpled up the paper, crossed it out with my pen.
Wait, aren't they perfect square like multiplication thingies?
Okay, I thought that too, right? But why would it not be something that you could easily factor? Because what technically should this be? Minus. Then it would be u minus 4, u plus 4. But no, since it's plus, we can't do anything. Okay. Any other ideas?
Well, 32 is looking suspicious.
Suspicious?
I don't know.
Okay, this is the exact process you're going to go through on the homework.
Make the whole,
Okay.
Make the whole bottom part negative and bring it to the top.
Make the whole, okay, I did that too. Okay, so I did 32 integral of u to the negative 2 plus 16 to the negative 1 du. I did this. Okay. However, when you go to, obviously I knew what the answer was, right? When you go to continue to solve this out, you end up with something that looks absolutely crazy. And that's what I did on this first try over here that I crossed out. Okay. So I'm going to tell you that, obviously I wrote in red, none of this is the right step. You need to look back at where we left off here. And remember, I said if you do completing the square, more often than not, it's going to be what? An inverse trig. Look at your inverse trig. Which one is it closely related to? Tangent. Okay, that's where I was too. I was like, it looks like arctangent. Okay, it looks like arctangent. I knew it was going to be arctangent. And then I just got stuck because I'm like, well, how am I going to get rid of this plus 16? This is what's throwing us off. So any ideas?
Wait,
Sit.
you took the 16 out, so you had like 32 integral the whole thing, and then like in parentheses put 16.
I can't take the 16 out, but I am going to do something with the 16. Someone said it. I don't know who said it.
This already said.
Not yet. We're going to divide everything by 16. Someone said it. I just didn't know who said it, right? Okay. I'm going to make it blue because I want to show you that we're dividing by 16. It's not wrong. So everything divide by 16. Everything. You're writing this now. If I write in red, don't write it, but you're writing this. Divide everything by 16. So now I have 32 integral of 1/16 x minus 2 squared over 16 plus 1. Do you see how we're getting closer to arctangent? Yes. I can, yes, I can take the 1/16 out from the top. So I have 32 over 16 integral 1 over x minus 2 squared over 16 plus 1. I'm getting closer. Dx. Okay, now what? What am I supposed to get in order for it to look like arctangent? Like u squared plus 1 or something like that. So I have to do something with this. Yes, I can do that. So what I'm doing here, so first of all, what's 32 divided by 16? 2. Integral 1 over, and I'm going to take this, that x minus 2 squared over 16, and we're going to put the 16 inside of those parentheses and square it. So in order to do that, that 16 is now what number?
32.
Okay, we're thinking backwards here, right? What do I need to square to make 16? 4. So this is going to become x minus 2 over 4 squared plus 1. Does everyone see how I did that? Okay. Which means I can now, after all the manipulation, identify u. And what is u?
X minus 2 over 4.
Yes, so let u equal x minus 2 over 4, which means du dx is equal to 1/4. Everyone agree? Yes? You're like, yeah. Okay. Which means that dx is equal to 4 du. Okay, we cross multiply. Okay, now I go back and plug it in. So I have 2 integral of 1 over u squared plus 1 times 4 du. And then I can do what with the 4?
Take it out.
Take it out, and I know 1 over u squared plus 1 is going to be arctangent. So this is 8 inverse of tan u plus c. Okay, and then I plug in u, because u is x minus 2 over 4. So this is 8 inverse of tangent x minus 2 over 4 plus c. That is my answer. Okay, it's not that bad, right? 'Cause we're walking each other through it. Okay.